Great. So when I was thinking of this reInvent and thinking of a single sentence that will summarize experience at reInvent, what came to my mind is a quote from a famous Italian-American race car driver, Mario Andretti. So what he said was, if everything seems to be under control, you're just not moving fast enough. So hopefully today's session and your experience in reInvent will inspire you guys to start moving faster. So that's what our session is all about. So one of the great advantages and great privileges of working at Amazon Web Services is the ability to see a really large group of customers and work with them. So after we work with them diligently for a number of years, we've seen a few very key trends in innovation, in advertising and marketing. So these 5 areas are data analytics and measurement. So for the most part, customers already learned how to build multi-petabyte scale data lakes, and they understand how to control data and how to bring data into the cloud. But doing it at cost, at low cost, that's what's actually very interesting. And it's actually enabled through technologies like serverless and technologies like Redshift and Athena. And modern data lakes are a lot more economical than data lakes that have been built a couple of years ago. So the next big innovation trend is real-time bidding in the cloud. So for the most part, we've seen a number of real-time bidding solutions being deployed in the cloud and migrated from colocation infrastructure into the cloud. Another very interesting topic that we've seen as far as innovation is concerned is identity. So it turns out that graph infrastructure and graph databases, purpose-built databases, are extremely useful for capturing the complexity of identity. And in advertising and marketing, resolving identity is a fundamental aspect of overall experience of the customer and providing that experience and mapping the journey. As you'll see, with modern measurement capabilities, customers are learning how to map the journey of users across multiple devices and ultimately see how this journey ends up in the purchase of product or a service. And ultimately, machine learning and personalization. So customers at this point already learned how to use machine learning over graph databases, and they also use personalization engines, and they also use Amazon SageMaker to derive very deep insight from the data and provide better customer experiences. So I'm really happy to announce today we have 3 customers that will tell their stories today. So we'll have Nielsen, the Trade Desk, and Segment, and we're very excited to have these guys on stage. But before we do that, I just want to summarize a couple of things and how Amazon Web Services empowers these customers to deliver the products and services they build. What exactly Amazon Web Services does. So the first thing that's actually a big differentiator for Amazon Web Services is actually the breadth and depth of technology. It comes down to a single word, choice. So when you have choice, you have ability to build the solutions that will accommodate your use cases and will be much more robust and resilient and scale better. So the choice of services is phenomenal. So this slide mentions 165 services that we currently have, but because of the recent reInvent announcements, that number is a lot larger, right? So not only we have a breadth of services, but we also innovate very, very deeply all the way down to the networking stack. I don't know if any of you attended a presentation on Monday night, and that actually talks a lot about the innovation in the hardware space, innovation in networking, and you can actually see how advertising and marketing customers take full advantage of that space. So one great example would be Trade Desk will be talking about AWS Global Accelerator and how that technology enables real-time bidding use cases. There are lots of innovation goes into data analytics, big data services, and all that innovation from Amazon Web Services allows customers to build much more resilient solutions. So the second reason why these customers choose AWS is cost leadership. And what's interesting here is cost leadership also comes from the choice. It's not just we have the cheapest infrastructure in the market, but it's also the choice of the right tools for the right job. That's very important. So here we have a situation when you have customers giving us feedback that in many cases, if you migrate your big data workloads from colocation data centers into AWS, you can actually save 70% of costs. And many reasons for that is because you're allowed to You build your serverless technologies for big data. You really try to take advantage of the native cloud infrastructure, and that's where these cost savings are coming from. They come from choice. So workloads can be tailored specifically to your needs, and you can actually have and pick up the workloads in services which have the right economic model. So the next thing is actually very interesting. Advertising and marketing customers also use EC2 Spot. EC2 Spot instances offer you 90% reduction in cost compared to traditional demand instances. And this unique capability of EC2 Spot allows customers to reduce significantly the cost of infrastructure. There are also a great number of examples how customers are using machine learning and other techniques to reduce the overall cost of operation. So ultimately, from ability to have breadth and depth of services and also have very low cost of infrastructure, you have ability to provide very high customer experience. Customers are literally delighted to use Amazon Web Services for a variety of different workloads. And that's actually why we see broad adoption when we have tens of thousands of data lakes deployed in Amazon Web Services. We also have tens of thousands of machine learning customers. So because of that, we have great adoption and we have very massive customer migration into the cloud. We also have very large adoption of Kubernetes. Over 50% of all Kubernetes deployments currently being deployed in AWS. So without further ado, I would love to invite Tim Nielsen here on stage, and we start working backwards from our customers. So this is how Amazon innovates. We listen to our customers very carefully, and we're really trying to make sure we understand the use cases and we try to offer them the technology that will solve their problems. So let me invite the Tim Nielsen on stage here, please. Warm welcome to Tim Nielsen.
All right, thanks very much for that kind introduction, and welcome to the session. Thanks for having us. My name is Scott Brown. I lead our television and audio ratings businesses at Nielsen, and I'm joined by Tejas Desai, who is our VP of Technology, who has been at the forefront of a lot of our cloud journey and transformation as a tech company as a whole. Before I get started, I just want to kind of share a funny story. Before I was planning to come out to Vegas, I was having a chat with my 2-year-old, almost 3-year-old daughter, and was telling, typically I travel a lot, and I tell her, what I'm doing, so she's aware that I'm traveling for work, and here's why. And so I told her I was coming out to Vegas to meet with Amazon, and she's like, what's that? And I said, well, they do the cloud. And she just looks at me with a blank face. And I said, the cloud. And she looks up at the sky and she says, clouds? And I said, yeah. And she's like, Dada, you make clouds? I said, well, not exactly. But what I'm here to do today is to talk about how our migration to the cloud has really enabled a lot of our new product innovation and growth and change as a company. And Tejas will talk about some of the details of the infrastructure and how the platform has been built. So in terms of what Nielsen does, I think we're best known as the television ratings company. But I wanted to kind of zoom out and kind of give a broader perspective of what we do and how we fit into the media and advertising ecosystem. So we really are the arbiter of truth in the industry. And what that really means is we're not a media company that creates media content. We're not an advertiser. We're not an agency. But we kind of sit in the middle of all of that. And we are essentially a technology company that creates data sets that fuel the buying and selling of advertising, that fuels how content is licensed, how it's distributed. And our data sets are really used as what we call the currency in that ecosystem to buy and sell advertising and to value content. And so that's becoming increasingly more important as the industry is experiencing a tremendous amount of change. Right? So the industry is experiencing change in terms of increased fragmentation. Consumers have more choices than ever before, but also there's more competition, right? There's networks that are creating their own applications, that are creating their own distribution platforms, and everyone is competing to get more eyeballs on their content. And while all that's happening and content is being proliferated across different digital platforms, there's other things that we have to worry about in terms of privacy, in terms of fraud detection in advertising. And so Nielsen really sits at the middle of that to try to sort through all of that noise to give our advertiser, agency, and media company clients the data that they need to make decisions. Now, the foundation and bedrock of what we do at Nielsen is really what was mentioned before about measurement. And essentially, our core purpose is to measure what the consumer does everywhere at any time, whether it's in your home, whether it's out of home, whether it's on a digital device, television device, what have you. And we're really measuring the full funnel of the consumer ecosystem to provide our clients a view of how consumers are viewing content online or on television, how that translates to their purchase behaviors, how other forms of media like radio and podcasting fits into the mix, ultimately to give that full funnel view to our clients for how they reach their target audience when they want and how they want to do it. Now, that has not been easy. As I mentioned, Nielsen has traditionally been known as the television ratings company, but the definition of what television even is has really changed over the last few years and is increasingly changing even in 2019 and in the weeks to come. We just saw the announcement and the launch of Disney Plus and how that has really changed the whole ecosystem in terms of how their content is being distributed and how that is reaching different audiences. Apple TV Plus has gotten into the game. Next year, HBO Max, NBC Peacock, and others are bringing new direct-to-consumer offerings to the marketplace. And so what that means for us is Nielsen has been ahead of the curve by modernizing our platform and moving to the cloud, because measuring that full funnel consumer experience requires extremely large data sets. It requires us to process it in more real time and to give our customers data that can help make decisions in an environment that is having unprecedented change over the last few months. And so that's really what has driven our journey to the cloud. Our journey to the cloud, I would say, has not been an easy or a traditional one. It has really been the culmination of a couple different things that I'll talk about on this slide. So first of all, Nielsen is a 96-year-old company, and that means we have a lot of legacy. And the legacy is great for a lot of reasons, but it's not great for a lot of reasons in terms of challenges for how we scale. So first of all, we had to take a lot of our existing platforms that have been around for decades and generations and retire them and migrate them to the cloud with AWS's help. We've also made two pretty major acquisitions over the last couple of years that have also been integrated into our platform. We acquired a company called Exalate a few years back that is a cloud-native DMP platform, and we've paired that with Gracenote, which we also acquired a couple years ago, that is the world's leading provider of video, audio, and sports metadata. Those were two cloud-native companies that we brought in and had to integrate while we were migrating a lot of our legacy applications. Now, as we're doing all of that, we're starting to get ready for how we really rebuild our traditional core television measurement for the future that I was just talking about in terms of, how do we measure streaming television? Because, as we all can see in the news, streaming wars is really dominating the marketplace. And so, ultimately it was a process where we were integrating acquisitions, we were migrating legacy applications, but as we were doing it, we were really refactoring and rebuilding a lot of the legacy to be built cloud native to leverage the most modern practices that we'll talk about here today. In terms of what it's enabled from a product and from a business perspective, I'll talk about a couple of things. So the most tangible thing I'll highlight is as we're trying to measure that full funnel ecosystem that is continuing to fragment, we need more data and it needs to be much more granular. And so historically, Nielsen had actually measured its ratings through a panel of about 40,000 households across the United States. Well, now going into 2020, we're measuring data from over 30 million households. And so this has transformed us from a company that was traditionally measuring something from tens of thousands of homes to tens of millions of homes, and now we're processing tens of billions of events every single day to make that happen. The other thing we're doing, in addition to measuring with more data sets and more streaming data is we're bringing a service to the market that our customers have been asking for the last few years, and that is measuring content out of home. So what that means is being able to measure advertising and content exposures when people are viewing their content in sports bars, restaurants, doctor's offices, gyms, airports, et cetera. And so really it's all about leveraging our new cloud-based platform with AWS to make all that happen at the scale that we need. In order to make that happen, though, we've really experienced three other things I wanted to highlight. One is obviously this seismic change has really changed our capital profile. But I think more importantly than that, it's enabled our developers and a lot of the engineers on Tejas' team to leverage the breadth and depth of services from AWS so that they're spending less time managing infrastructure and selfishly spending more time on the products that I need them to build. And it's really been a game changer for us, and we've seen an increased level of velocity and, frankly, morale boost with our teams who are learning cloud skills, who are partnering very closely with our friends at AWS to improve their skills and to really enjoy what they're doing with us. It's also drastically simplified our disaster recovery strategy. So as you might imagine, Nielsen provides data that drives over $70 billion of advertising in the US every year, so we can't be down, we can't be late. And so we've worked very closely with AWS to improve our DR strategy. And the last thing I'll touch upon, which segues into what Tejas is going to talk to us about, is that measuring all those different platforms, integrating first-party and third-party data sets at much larger scale is all underpinned by really complex methodologies and machine learning algorithms that our data scientists have been hard at work on. And I would say that culturally, the biggest change that has really enabled us to build things faster is the advent of what we call our media data lake, which has really democratized access to data within our organization to allow our data science teams and our engineers to partner to build these models at greater scale than ever before. And so Tejas, why don't you talk a little bit more about that and how the platform has enabled it?
Thank you, Scott. So, as Scott mentioned, this has been a fairly long journey. I'm going to share with you a little bit about what this journey has looked like from a technology point of view and what it has enabled for us in terms of product development as well as other capabilities. I'll cover this from two different aspects. One is from the point of view of our technology platform that you see up here and how that enables our product development. And the second, which I'll shortly go through, is a solution we are building that modernizes the way we collaborate with our clients. So as I go through both of these, there's one thing I want you to keep in mind. At Nielsen, data science is in our DNA. And what that actually means is that for any architecture we design, any solution we design, our clients are obviously at the forefront, but so are our data scientists. So let's go through this platform architecture. I want to actually start at the bottom. At the bottom of this platform architecture sits our data lake that Scott mentioned. And the data lake is what really underpins the entire design of this architecture. The data lake has been designed with one principle, which is offer a low barrier to entry for any application team that's trying to build any service, any application, any process on top of it. And we achieve this in two ways. One, all the data that sits in our data lake is in a open source Parquet format with a single Hive metastore. Second, all the data that you see dropping into the data lake in this pipeline from left to right is immutable and versioned. These two principles actually create something very powerful. We now have a single source of truth for all of our data sets, and through the open source framework, there's easy access to this data for all of our application teams that sit on top of it. What it also does is it separates our compute from storage in a way where you can build your services and applications focusing on the right technologies, right services, right open source frameworks that suit the best for your use case without access to the data being a constraint. So what do I mean by that? Let me give you some examples. If you look at the middle compute layer of this platform, to the very left, we have our collection systems. These are the systems that bring in information from our panelists as well as broader sources that Scott was talking about. After that, we have our data processing systems, and these systems take that collected data, enrich it, harmonize it, apply our methodologies on that data, and prepare it for the downstream client-facing applications to surface insights from this data. So where we have achieved a greater level of scale, flexibility, and multi-tenancy is with this separation of storage and compute, we are able to build services across this pipeline, leveraging the technologies that suit each service the best. So for example, if you look at our data processing, there's two aspects to it. We do long tail analysis on our data where we apply our methodologies. For something like that, we use Redshift that enables certain capabilities that wouldn't be available otherwise. But we also have cases where we do more smaller batch processing. And for something like that, we would use EMR or Spark to do more ephemeral transactions. Further downstream, if you look at our client applications, they sit on top of this raw data that has come out of our processing pipeline. Through the capabilities we now have through this platform in AWS, we can take that data out of the data lake, materialize it based on the use case of an application, drop it into a data store, and again, that data store could be Postgres, could be Elasticsearch. You can pick the technology that suits the need of your application. We can build a layer of compute on top of it, leveraging, again, technologies or machine learning models or AI that are appropriate for surfacing insights from that data. And furthermore, on top of that, we can bring in other technologies such as Superset to build rich dashboards and BI solutions. Above that, we have our end-to-end orchestration and service layer, where we leverage Airflow to manage that orchestration of this pipeline seamlessly from one end to the other. We leverage Bitbucket Jenkins to offer CI/CD as a service across our development teams. And this is what really forms the whole ecosystem of our platform. And really, the strength of this design for us is that by separating the compute and storage, as I mentioned, our application teams are free to leverage the best technologies, the best open source frameworks, and the services that AWS has to offer to build all of our products independent of any constraints in terms of access to our data. So now that I've talked about our technology platform, I want to talk about the solution that we are in the process of building that will modernize the way we collaborate with our clients. Intelligence Studio is what we are building, again, on top of the same data lake that I talked about before. Intelligence Studio does something that we do really well at Nielsen. It enables a software development lifecycle that is focused on data scientists and building statistical models as opposed to pure software development. Through the underlying compute that Intelligence Studio offers, internal or external data scientists can come in and operate on various data sets and build out methodologies and models that would have otherwise not been possible. Of course, all of this has to be done with security and privacy in mind. So we are actively working with AWS to make sure that we have the right access control, right entitlements, and right privacy in place across all three tiers. But ultimately what this achieves and enables is the ability to act and build on this data in a truly democratized way. So with that, I'll hand back to Scott.
We're running short on time, so I'll just say thank you for allowing us to share a little bit about our story and our transformation. Tejas and I will be around all week if you'd like to reach out to us to learn a little bit more about the platform and how we built the data lake. We're totally open to sharing more feedback and to getting advice from others too. With that being said, I'm going to hand the stage to our friend from Segment and get on to the next part of the presentation. Thank you.
Thank you.
All right. Thanks everyone for having me here, and thanks to the AWS team as well. I'm Calvin, one of the co-founders and CTO of Segment. Now, before I dive into the talk and start getting into the nuts and bolts of data infrastructure and managing customer data well, I wanted to start off with something that's maybe a little bit more universal. And that's this idea of achieving enlightenment. Everyone wants to feel fulfilled, they want to have purpose in life, and don't worry, you'll see where I'm going with this in just a few minutes. But everyone's been thinking about ways that they can climb this mountain to fully just feel fulfilled. And people have been thinking a long time about how to actually do this well. And in particular, there's this one guy who I think you may remember from your college psychology class called Albert Maslow. And he came up with this framework for achieving enlightenment. And in his case, he said, well, there's kind of this pyramid of needs that you have. At the really base layer, you need all of these basic physical needs, whether that's food, water, shelter. And then as you move up, you need some sort of safety and sense of belonging. And then as you finally move up that pillar, you can finally achieve that self-actualization, that level of enlightenment. Well, today, I'm not quite going to talk through all that. Sadly, I don't have the keys to enlightenment. But we'll be embarking on our own data journey here and talking about something similar that I like to call the journey to data enlightenment. Now, why is data enlightenment important? Well, a lot of you out here are trying to accomplish things like personalization, creating this unique, world-class customer experience for all of your customers that's totally unique to them. And at Segment, we start with this belief that really every company in the world today should be able to provide that world-class level of customer experience. But the problem is that as relationships increasingly move online, where customers are interacting with you across mobile apps, websites, maybe internal tools that you have, it becomes really difficult to get that customer relationship in that single view of the customer. And so that's where turning to data comes in. And at Segment, we try and solve for this problem of providing this world-class data infrastructure to collect data, manage it, and organize it. We help companies gather their customer data from their websites, their mobile apps, or other tools they might be using like Salesforce or Zendesk. We help unify that data into one single consistent view, and then we help them activate that data in more than 300 different destinations, whether they're help desks, email tools, or advertising tools. And by the numbers, that's actually taken us to some fairly interesting places. To give you a little sense of our scale today, we're processing about 450 billion events every single month. 19,000 companies are sending us data from smaller startups like Instacart or Envision, all the way up through the big enterprises, folks like IBM, Intuit, Levi's, or Meredith. And to power all that infrastructure, we're running about 16,000 containers on ECS, taking that real-time data collection and fanning it out to all these places where that data should go in about 1.3 seconds. But on our road to data enlightenment, I'd argue that personalization is really this peak, this place that we all want to get to, that we all want to reach as companies and leaders. But in order to get there, we have to invest a lot in some of the fundamentals and the foundations. And so I'm going to spend the majority of this talk talking about how we get to that data foundation and sharing some of the techniques that we've learned at Segment, literally working on this problem for the past 7 years. And then from there, we'll talk about how we govern that data, and then finally, actually how we personalize it. So let's get started. Let's discuss that data foundation. Now, I'm going to discuss 5 lessons that we've learned over the course of building Segment, starting with collection, through data processing, to actually activating that data and archiving it appropriately. Let's start with the collection piece. Now, there's one big rule that we've learned with collection, and that's that you have to meet the developer on their level. How many times have you chosen a vendor where they promised you the sun and the moon, and you found out that it was just really hard to even get data into that vendor in the first place to actually get those results that you wanted? Well, we found that there are kind of a few keys to doing this well. The first is that you have to give developers libraries that meet them in their language, in the tool set that they're using day to day. It can't be some API that you have to build a bunch of code for. It has to be something that's easy and intuitive. And particularly for collecting analytics data, you want to make sure that you never block the core functionality. You can't break someone's website or app just to collect the metrics that you need to power other parts of your business. For us, we built out libraries for a number of different languages. Ones for iOS, Java, PHP, client-side JavaScript. And we've tried to give them a simple, intuitive API that's easy for anyone to understand. In our case, that comes down to who is the user, what do I know about them, their first name, their last name, their email, and what is it that they're doing? Are they viewing a page? Are they signing up for a new product launch? Are they adding an item to their cart? Are they completing checkout? Rule number 2 comes down to the kind of second piece of this on collection, which is just never losing data. How many times have you looked at a report and you've said, this doesn't quite seem right. I don't trust this data. I think some of it's missing. Well, in our case, we've invested a lot in trying to make sure that we never, ever, ever lose data. And that really starts at the front door for data collection. You want to make sure that that front API is really performant and it's scaled up. For us, we actually have heavily profiled this. We're running a set of Go servers at the front door that an ALB directs traffic to. And we intentionally keep those scaled super far up. So we're only using about 10% of capacity on that front door just so we can deal with sudden spikes that might 2 or 3x traffic in the course of 5 minutes. One useful technique we found is also to keep that edge stateless. You never want to be relying on a single database to process traffic. You want to be able to always accept it no matter what parts of your network are down. We try and use queues or a tool like Kafka or Kinesis everywhere to be able to accept all of that load, even if the rest of your infrastructure has time to scale up. In our case, it looks a little bit like this. We have these public endpoints with what we call our tracking API, which is an ECS service written in Go, which is running on our set of edge nodes. Those publish locally to this queue called NSQ, which then we have a set of internal tools the rest of our pipeline reads to process data through the rest of the pipeline. What that means is that that edge node, that tracking API box, is totally stateless. It doesn't require a network. It doesn't require a database access. It can just always accept data. It means that the rest of our infrastructure can scale up and down to process it as it comes in. Okay, so meet developers on their level, keep the edge stateless, always accept data. What about processing that data? We found talking to a bunch of customers that they need to do a lot of work when it comes to building their own data pipelines to validate incoming data, enrich that data with new fields and attributes, filter it out for fields that they don't need or maybe enforce particular pieces of schema, and then transform it to meet the spec that they want. At least in our case, the number one lesson that we've learned here is this idea of separating control and data planes. And what do I mean by that? Well, you could think about our system as being the set of services which are chained together by queues. We have an incoming API, that front door that I talked about, and then the real-time system kind of streams through these different services, each of whom are designed to do something different, whether it's that enrichment, that filtering, that processing, that transformation. Now, each one of these systems requires a database to figure out where data should go and which data should be filtered, right? Like the GDPR endpoint or the GDPR service is going to look in that database and figure out whether we should suppress a given user for GDPR. And this works great for a while until your pipeline gets sufficiently big, and then you start having problems. Let's say one of these databases goes down. Well, now you're kind of out of luck everywhere, right? Like suddenly you can't process data going through anymore, and it means that your entire pipeline has gone down, even though there's just a little piece of it which isn't working. Well, to combat this, we've split up our infrastructure into what we call the control plane and the data plane. The idea here is that your application or your visual configuration writes to this control plane, this set of DBs, and then we mirror copies onto each of our services locally. And actually, in our case, we use SQLite databases. We use these little embedded databases, which you can query locally. They're basically always available. And we've invested a bunch to make sure that our pipeline doesn't go down even if one of these databases happens to die. So this is hands down one of the best architectural decisions we've ever made. We talk about it more in this blog post here that I linked to, and we've actually open sourced this infrastructure as well. So if you want to check it out, you can go to our GitHub and check out Control Store, where you can spin this up in your own infrastructure. What about archiving this data? I'll only spend a little bit of time here, but the basic rule is that you always want an archive, no matter what. We see the archive as essentially our insurance policy. It's a set of raw logs that we can always come back to no matter what set of processing happened earlier, kind of like the immutable data structure that the previous folks at Nielsen talked about. In order to do that, we have a set of archivers which are uploading to S3 on an hourly basis. And then we also run an ETL process for a bunch of our bigger customers who are using data warehouses. They can load this into their own S3 buckets or into their own Redshift instances or a warehouse like Snowflake. And for them, it really allows them the flexibility to get these really fine-grained queries that they want to answer. Our top rules here are that you should always just keep the data somewhere. S3 is incredibly cheap, and so there's no reason not to store data there. Similarly to the folks at Nielsen, we recommend Parquet encoding that data, so it's easy to scan with built-in tools like Athena. And you'll always want to load it to Redshift as well for more interactive querying. Lastly, let's talk activation. Data is really only as good as the experiences and the analysis and the insights that it's providing. So we've invested a lot in making sure that that activation works flawlessly across hundreds of different tools. Our number one rule here sounds dumb. It's just retry, 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 but it actually has really big consequences. Now, as I said before, Segment sends data to 300 different services across the internet. You might imagine that each of them is relatively well run, and so maybe they have downtime just once a year. But at least on our side, that means that we're seeing downtime about once every other day or so. And what that means on the public internet is that these APIs will fail. They're going to go down. And so you really have to plan for that in your architecture and in your designs. And in particular, you need both retry logic and visibility. And so we've invested a bunch in building out our solution to this problem, which we call Centrifuge, which I linked to the blog post here, but I can give you the very quick definition of it. Essentially, what you might think of as like a fairly nascent architecture would just be having a queue and then having a worker which reads off that queue and sends data to Google Analytics or Mixpanel or Salesforce. But that creates a problem. Let's say that Google Analytics latency suddenly spikes 10x to where it was. Suddenly you're now creating back pressure on your entire pipeline if you're trying to send this data somewhere. So you want to be able to split up these queues not only by the place that they're going, but also by the input payloads, because certain payloads might cause worse behavior than others. To do this, the very high-level explanation is that we've replaced these queues with a set of databases. It allows us to reorder jobs on the fly to be delivered to various destinations so that we don't have to shuffle a bunch of megabytes or gigabytes from one Kafka broker to another. Instead, it allows us to selectively query for what data should be sent so that we can adapt on the fly to new workloads. Additionally, the two key pieces of this infrastructure are, one, to archive any messages that fail. This goes back to the always wanting an archive. You always want a trace of messages which couldn't be delivered for some reason, in addition to retrying as much as you can. And you want to give your users a window into the reason why. We've invested a bunch in building in observability as a first-class primitive into the product. But when most of our customers end up coming to us and the reason they end up choosing Segment is because they have problems in their own organization. They say, hey, I'm seeing discrepancies between Google Analytics and my warehouse. Or I feel like this piece of data has gone missing. Or for some reason, for a week of data, it just looks different, and I'm not sure why. So make sure you give that visibility to your internal customers as well as external customers. So those are the pieces of establishing a data foundation. Meeting the developer where they're at, never losing data, separating those control and data planes, always keeping that archive around just in case and for replay scenarios, and then continuing to retry and retry and retry to deliver data. On average, we see about 1.8% improvement in terms of data that failed the first time, but then made it through the second time. Okay, so let's move up that ladder. We started with the foundation, let's move into governance. We really approach governance from kind of two layers. One is around filtering and schema enforcement, and the other is around privacy. On the filtering side, you want to make sure that your tools allow individual teams to define how their data should be filtered and sent at any stage of the pipeline. Teams should be able to say, oh, I want to strip this field, or I want to rename this other one, or maybe I want to send all of my data into my warehouse or data lake, but filter it from a tool like Google Analytics. You want to make doing this the right way, the easy way. Start with a tracking plan and make it easy for the rest of your teams to adapt. The other one is privacy, which is actually a really hot topic recently that I'm sure is on many of your minds in the audience. What we found is that there's increasing push for legislation, not only in the EU, but now in the US with the CCPA coming out later this year, as well as many other jurisdictions, Germany, Australia. We're just seeing everywhere in the world become more privacy conscious. What this means is that you have to build your systems now with deletion in mind. So instead of building architecture where it's traditionally this log where you're just adding events or updating them or reading them, now suddenly you have to build deletion to be able to delete at any random point in that log in your data pipeline. We've invested this as a full product. We actually created a GDPR endpoint that deletes this data, it suppresses new users, and it actually federates out to a bunch of those tools that I mentioned earlier. But if you're building your own pipeline, you have to take care to respect the user as well. And lastly, let's get back to achieving personalization. In many ways, achieving personalization has really never been easier. You can use products today like Amazon Personalized, which a number of our customers are using, where they feed that segment data into Personalized to generate personalized content or product recommendations based upon that user's browsing history. We also have a product called Segment Personas that allows marketers to easily create audiences across all of their users that they can then sync to Facebook, Google, and other advertising tools. But the one message I want to leave you with is that you really need that data foundation first. Personalization really comes down to garbage in, garbage out. If you're not focusing on collecting the right data at the right times with the right schema, your personalization efforts aren't going to go anywhere. And it's just going to be wasted effort. And there we have it. That's how we get to data nirvana. We focus on the foundation, decoupling these control and data planes. We've added governance controls to let our privacy teams work independently of our engineering teams, independently of our marketing teams. And by focusing on that good data, it's really the first step towards good personalization. I hope you'll agree that in this case, we've achieved the first little step towards data enlightenment, and hopefully you've learned some lessons to take back to your organization. At any rate, I think Maslov would be proud. Thank you.
Thanks, Calvin. One of the pains about going last is you have to follow great presentations, and that's the pain I have to bear. My name is Zach Stengel. I am the SVP of Engineering at the Trade Desk. And because I know not everyone in this audience is familiar with the Trade Desk, like my fellow presenters, I'll take a couple minutes at the beginning to give you a sense of who we are and what we're about, and then tell you how we have brought one of the world's most highly scaled internet applications to the AWS cloud. But first things first, the Trade Desk is a SaaS platform that enables our clients, who are media buyers, typically advertising agencies, to make data-driven purchasing decisions on individual opportunities to deliver marketing messages. Essentially, we buy ad space at massive scale in real time. But more important than what we do, at least to us, is why we do it. The Trade Desk was founded on a belief that the future of media, so everything from what I would consider to be today's golden age of television to news stories that shape our world, all of it depends on the quality and the efficacy of advertising. One of the greatest things that I think I will see in my entire lifetime is the era of unprecedented economic expansion that we're seeing in the world today. Over the next 10 years, 1.5 billion people will climb out of poverty and enter the global middle class. And this has already doubled over the past decade to now include over half of all the people on the planet. And these two macro forces, the fundamental transformation of media, which I think everyone in this room is living day to day, and the just extraordinary rise of the global middle class, mean that the scale and the importance of advertising are both going up dramatically. And the old way of doing things, it just won't work anymore. So the days of billions of dollars being transacted in bulk over a handshake in a deal where the advertiser has very little insight over what they just bought, and the publisher has to sell their content at a discount because there's no sophisticated buyer in the world that will pay a premium for a black box. Those days are numbered. The just fundamental laws of economics demand that marketplaces get more efficient and more transparent as they scale. And that is where the trade desk and companies like us step in. So in the industry, we're known as a demand-side platform or a DSP. But if you don't know what that is, you can sort of think of our platform like a search engine kind of turned on its head, where instead of processing a stream of unstructured queries from regular humans against a relatively structured or a relatively static set of semi-structured documents, essentially looking for information, our platform applies a set of relatively structured queries designed by marketers, who I guess are regular humans too, against a stream of highly dynamic events, essentially the corpus of human behavior on the internet. And what we are searching for are the combination of audiences in a particular context who will at that moment find a specific message relevant to them and respond. So DSPs like the Trade Desk fit into an ecosystem called programmatic advertising. And I'll spend just a minute to give you a refresher course or a crash course on the basic mechanics of programmatic advertising. I know many of you are familiar with it, but it's important to understand why bidding in the cloud is such a challenge. So programmatic advertising was modeled after our financial markets, where at the center are advertising exchanges that operate in a way that's analogous to like the New York Stock Exchange or the NASDAQ. The place where an ad will be rendered is represented by some kind of container. So on the web, this is typically an iframe, but it can be other kinds of technologies depending upon the context. So it's different for video or mobile or audio, et cetera. And this container, when it's rendered, will cause the user's browser to send a request to one of these advertising exchanges. That exchange then holds on to that request and sends calls out to buyers who are registered on that exchange. And these are DSPs, and the Trade Desk is one of the largest buyers in the world. Each of these DSPs then makes their own decision based upon their own data and algorithms about how to value that opportunity. And of all of the messages that they could deliver, which one is going to be most effective at that moment. They then respond to the exchange with a bid, which is essentially the price that they're willing to pay, and the code to render that ad if they're selected as the winner. The exchange then runs an auction and delivers the ad rendering code of the winner back to that container to be rendered. And because this is all happening in the context of a user consuming content, the latency requirements are relatively strict. So for example, the Trade Desk responds on average in about 1/100th of a second, about 10 milliseconds. But taking a step back, what this model really does is open up advertising's black box to put the buying decision in the hands of the buyer, leading to higher return on their advertising dollar. It also eventually leads to higher yield for publishers because, again, advertisers will pay a premium when they have the opportunity to make an informed decision. And it also leads to a fewer number of higher quality, more relevant ads, which I think we all as consumers can agree is a better experience for everyone. But the key challenge here is scale. Every single campaign is looking for a needle in a gigantic haystack. I mentioned earlier that there's an analogy between our platform and a traditional search platform. But one of the important ways that we're different has to do with scale. Because instead of processing about 6 billion queries a day, which is roughly the combined scale of global search, our platform processes over 800 billion queries every day. That's well over 100 times the combined scale of global search. Because instead of monetizing just a single website or portal, the Trade Desk has the opportunity to monetize the bulk of the open internet. And the internet is, as it turns out, really, really big. And this scale in terms of query volume obviously has ripple effects throughout our entire technology stack. And aside from being, for an engineer like me, a ton of fun, this has made our journey to bidding in the cloud a relatively circuitous one. So I want to take a moment and tell you what that journey has been like for us, and then give you a little bit of a peek under the hood to see how, with our tremendous partnership with AWS, we have achieved something that we once thought might never be possible. So we actually started our operations in the cloud with AWS in 2010, nearly 10 years ago. And we have had a major presence in AWS ever since. But in early 2011, many new supply partners, those advertising exchanges, were coming online in regions that at the time AWS wasn't close to. So we actually at that time moved the bidding portion of our technology stack to another cloud provider that again at the time was closer to those new supply sources. But as these new sources of supply came online, we found that our query volume quickly 10x'd, then 50x'd, and within a year, we brought down that other cloud provider's entire data center operations. And so in mid-2012, we actually moved our full bidding workload to physical data centers with managed support. And for the next 5.5 years or so, this was essentially our strategy. The highest scale portions of the Trade Desk workload would run in managed physical sites, and everything else would run in the cloud. But toward the end of 2018, two things happened that began to shift our strategy. First, it became just abundantly clear that our strategy of managed physical bidding sites just wasn't able to keep up with our growth. So for example, procurement was a major challenge. It would take 3, sometimes up to 6 months to procure new hardware, which made it really difficult to stay ahead of our growth curve. We also had a profound lack of insight with no physical connection to, or no direct connection to physical layer monitoring. Everything happened through a third-party NOC. And we also had a lack of control because changes at the lower levels were done through tickets, which would make it take hours or sometimes days to do what our own team could otherwise have done in minutes. The second major development, though, was actually the launch of Global Accelerator at reInvent last year. The sheer size of our bidding workload and its latency requirements, along with how dynamic it can be, pose some really significant challenges to load balancing solutions. But we began testing Global Accelerator shortly after its public release. And even though it's not, it wasn't designed explicitly for our use case, is actually a really good example, I think, of the agility of the AWS team in working with us to hammer out a solution that was a little bit out of the box. And we found that it worked for our workload. And this was really the final development that let us shift toward a cloud bidding strategy. We started with our smallest site in AWS Tokyo, but then have moved on to progressively larger sites in Singapore and now in Frankfurt. And this is what the picture looks like today. We have 15 sites around the world, with our 16th in Hong Kong coming online soon. We have adopted essentially a hybrid approach that mixes physical data centers with cloud data centers around the world. We have cloud bidding sites across Asia and now in Europe. We have physical bidding sites in North America, one still supporting Europe. And then we have cloud services sites in locations close to end users around the world. To support this hybrid approach, we've developed an infrastructure that is largely environment agnostic, but at the center of our global operations is a hub in AWS. And to give you a sense of what that looks like, here's a sort of 30,000-foot view of our global architecture. So notice that whatever site is along the edges, AWS is at the center of our global operations. So all of our sites produce log information that's offloaded to S3 as quickly as possible. An ETL process then kicks off that transforms and loads that data into Vertica running in Eon mode on top of S3 as our primary data warehouse. That data plus real-time feeds from our bidding sites feed it into our global budgeting service that coordinates budgeting and pacing worldwide. We run many different kinds of ML workloads on top of EMR and Spark and several other technologies that produce things like our identity graph and models that will automatically shift budget on the fly to higher performing pockets of inventory. And our front-end services also run out of AWS. And all of this runs on top of a suite of core AWS services, including CloudFront, EMR, as I was talking about, Lambda, RDS, which houses much of our operational data, and increasingly EKS for service orchestration. And many of the bones of this have been in place for several years, but our move to bidding in the cloud is relatively new. So I want to zoom in a little bit and give you a sense of what that looks like. So that hub that I was just talking about is the VPC over on the right. On the left is essentially the anatomy of a trade desk cloud bidding site on AWS. So a few highlights. We actually use all four of Amazon's load balancing technologies. Global Accelerator, as I've talked about, for our highest scale workloads. NLB for data ingestion, which is also high scale, but not nearly as high as bidding. ALB, where we need layer 7 routing, and CLB for some simple internal workloads. We also use Aerospike as our real-time NoSQL database. This is another great example of partnership with AWS. Aerospike is a fantastic database, but it has some specific hardware requirements to meet the latency demands of a platform like ours. And we were able to work with the AWS team to design a solution that really meets our needs. I've expanded our global budgeting service a little bit on the right to give a bit more detail, showing we use Kafka messaging for fast, reliable, and globally coordinated budget and pacing communication. And again, we use Vertica Eon as our primary data warehouse running on top of S3. So moving bidding back to the cloud was actually a really big bet for us, but it has already paid off in some significant ways. So I want to cover just a couple of the wins that we've been able to realize already. So first, the build time for a new site has been cut dramatically. So it used to take 3 to 4 months, sometimes up to 6 months to build out a new site, and that's down to 2 to 3 weeks. And most of that time is actually just hydrating caches. We can actually do the physical build out in a week or less. We have much more agility now. So we are able to iterate and tune these environments much more frequently. We'll submit more changes to one of our cloud sites than we typically would in a year in one of our managed physical sites. We also have better talent utilization. So even though AWS is obviously a highly virtualized environment, we actually have much greater control, which lets us better utilize the talent that we have in-house. And finally, costs we found were neutral to a little bit better depending upon the site. And this was really key because the trade desk has been interested in the beginning in building a sustainable business for the long term. And we could have moved our bidding workload to the cloud much earlier than we did, but to do it cost effectively and at scale is a whole other kind of challenge. And we would not have been able to meet it without our tremendous partnership with AWS. So I want to close just by saying thank you to AWS and to all of you for listening. Thanks.